Hello everyone. This is Zhou Donghui number 2. So here I will guide you through some interesting features of SAM's online demo. So as my colleagues have introduced, SAM is first pre-trained on so-called segment anything task designed by the authors. So this model is trained to give segmentation results based on input prompts, which can be a set of points or a rough box or mask or even some free-form text prompts. So this online demo mainly reveals SAM's ability given these like in distribution inputs. So we will firstly click on a random example image to see the model's performance. Maybe we will choose a more complicated one. So for example, this city image. So now we are first at the hover and click feature. So as we move our pointer, you can see that the possible segmentation suggestions. If we set our pointer, if we set the point prompt to a corresponding area is shaded. So if we click to make a point prompt, we can see that the segmentation suggestion given by SAM and the performance of the model is actually quite satisfying, since like it successfully identified the building parts separated by the bridge. And as we can see that this single click only reveals the highest confident solution of the model. So if we want to see all the segmentation suggestions with a given point prompt, we can use the multi-mask feature. So if we select multi-mask, we can see that here a 3D visualization of the segmentations is shown. So for example, we see that for the same point prompt, they can have different segmentation results, like the top part of the building, and also the bottom part of the building, and even like some front parts or side parts, sides of the building. Also, we can make the prompt a set of different prompts. To make the prompt a set of different points. So for example, I can click to create multiple points to make the whole prompt. And the model will also do segmentation based on all the points selected. But we can see like the performance of having random points on the buildings is not so accurate, because like there are some parts missing. But like for example, if we select all the points on the same background, you can see that the performance is quite good, since the background is just one segmentation of the image, instead of if we select multiple separate possible segmentations like within the buildings. And then we will explore the next, which is the box prompt input feature. So this one is then rather straightforward. If we draw a box on the image, so for example, this is a box, and the model will give possible segmentations of the selected area. So note that the model actually still takes the whole image as the input. So if I make selection like this, so actually the segmentation can actually fall out of the boundary of the box. And the box prompt, it has the same problem as the point-wise prompt, which is that if I select, for example, I select too many basic segmentation objects within my, within my box, then the performance of the segmentation is not as good as like selecting a small region. And also, I find it very interesting that if we select a region with background and parts of the foreground object, so for example, I select part of the building and part of the sky, and actually the model tend to predict the background instead of the foreground. Yeah, since this one I select all the foreground image. So for example, like this would be like predicting a background, and so like this will also predicting the background. And also both the box and the clicked, they all have a feature called cutout object. So for example, this is the result of the point selection. And so I click cutout object, it will be cut out into the cutouts, so that this segmentation can be like used to analyze, like do some future analysis. So finally is the everything feature. So it is to enumerate all the points on an image and to perform segmentation on each one of the points, so that the whole image, so that like as a whole image wheel, all the segmentations are presented together. Of course, the segmentation here presented is the highest confidence prediction, like by Sam. And this is actually an in-distribution, which is like an image of their own. And actually, we can upload our own images. So for example, here is a